split in half, but we still have some of the accessory glands left on this side. So that is your ample of the ductus deferens here.
Oh,
Okay. So that is ductus
Cute.
deferens running through the vaginal ring. That is supposed to go back to the scrotum. Okay. Ductus deferens with end of the ductus deferens with dilated part, which is ample of the ductus deferens. And if I now try to go into the membrane here, I'm going to find the prostate gland as well as the vesicular gland. The vesicular gland first, and then the prostate gland. The vesicular gland in the horse, like if we try to look at the description, it says like it is pear shape or something, but when it is full, when it has seminal fluid or vesicular fluid into it, then it will look like that. Otherwise, in the collapsed form, it is just going to look like collapsed bladder also. Okay. Okay, so let's come back to the limb. So that is the medial aspect here. We see the gracilis, which is being transected. We also have your semimembranosus on this side, as well as we have the adductor muscle. Okay. Then that is your sartorius. Just make sure I finish. Okay. Okay. So there is vastus medialis, rectus femoris. Then we have vastus lateralis on the other side. All of these are your quadriceps. This is your sartorius. We reflected the gracilis. Then we see the adductor with adductor brevis, pectineus. That is the semimembranosus, which is coming towards the proximal end of the tibia, which basically is going to function as one of the major flexors of the stifle joint. Okay, by inserting on the tibia, it's going to flex the stifle joint. While all of your quadriceps, they're going to extend the stifle, and also your tensor fascia lata. By means of fascia lata, which is present on the lateral and partly on the medial side of the stifle, it will also extend the stifle joint. Okay? What structure is this? Let's try palpating that thing here. That is the patella. Then I can feel the cartilage on the medial side of the patella. What cartilage is that? That is parapatellar fibrocartilage, which is very important in locking mechanism of the patella. So what ligament is this? Medial patellar ligament. Then if I go with reference from the medial patellar ligament, I can go to the intermediate one, and then I can go to the lateral one. Okay, so we have medial, intermediate, and lateral patellar ligament. The intermediate looks slightly embedded or slightly hidden in the fat. Okay? So that is the infrapatellar fat body, which is usually present in the stifle joint. Okay? Most of the animals' stifle joint would be accompanied by this infrapatellar fat body, which usually helps supporting the stifle joint. Okay? So these three ligaments. Now we're going to have a few ligaments from the patella to the femur, but again we're not going to bother much about them because those are like the minor ones. Their important function is to keep the patella in place. So three patellar ligaments. Then what structure is this?
tibial tuberosity.
Tibial tuberosity. Then I can feel or I can palpate the crest of the tibia, and on the other side, which is the lateral one, I can see the groove for the passage of the muscles or passage of the extensor muscles. What do you call that? Extensor groove or sulcus muscularis, which is specifically for the extensor muscles. Okay. Okay. Then, as we see, some other things I can palpate there. That is the proximal end of the tibia. That is the distal end of the femur, epicondyle, as well as lateral tuberosity of the tibia. We have your medial collateral ligament is going to be present here, but again we're not going to use it as much as we can use the lateral one, because lateral one we're going to palpate more often in order to find the place to inject into the lateral femorotibial joint. Okay. What about connection between these two? How many animals has connection between the femoropatellar joint and medial femorotibial joint? Okay. All of them. Okay. All the horses, they have connection between these two, but only 25% have connection between the lateral and this one. Okay. Okay, as we move more distally now, like these are the crus or muscles which are extensors of the digit and flexors of the hog. or flexors of the digit and extensors of the hop. Okay, but before we go into that one, let's go to the lateral side of the gluteal region and identify some other muscles. Okay, so what about this region here? Everything which is covered in fat at this point is the gluteal muscles. Okay, so we have superficial gluteal, which is located more caudally, which would be in the form of two branches coming from the third trochanter of the femur. The structure I can palpate here is the third trochanter, and we have two divisions coming from the third trochanter going towards the gluteal fascia, and also the caudal division goes all the way to the sacrum, and so that is your superficial gluteal. Now between two heads or two divisions of the superficial gluteal, we have the middle gluteal, which continues with what muscle system?
Longissimus.
Longissimus lumborum, okay, which helps in rearing, which is lifting the animal body, or like 4/4 of the body and resting the all the weight on the hind leg. Okay, so that blends with longissimus lumborum. Now as we come more caudally, then we see the biceps femoris with three divisions: the cranial, middle, and the caudal. Though it is biceps, it's going to have three parts. The cranial part inserts on the lateral patellar ligament. Then we have the middle part going more towards the cranial end of the tibia, and then we have the caudal part, which is going more towards the common calcaneal tendon. Okay, so this part is part of the common calcaneal tendon, which is going to extend the hop joint. While this one here is more associated with the lateral patellar ligament. What is the function? Remember, something associated with the patellar locking and unlocking. It unlocks because it rotates the patella laterally by 15 degrees angle or so, and it will help unlocking the patella. Okay, so that is the cranial head, middle head, and the caudal head. Middle head simply help in the flexion of the stifle joint as the semimembranosus muscle. Then as we come more caudally, then we see the semitendinosus, which exclusively becomes part of the common calcaneal tendon, extending the hop joint. At the same time, all of these muscles can also collectively flex the stifle because they are located on the flexor surface of the stifle. Some of them, they would still be able to extend the hip joint because they are located on the caudal part or extensor surface of the hip joint, so they would also be able to do that, but really that is not their major responsibility. Okay, the major responsibility of extension of the hip joint is the middle gluteal. Along with other gluteals, middle gluteal is going to be the most important one. Okay, now when you look at these muscles on the lateral side, we still see the craniolateral aspect. We have tensor fascia lata as well as the quadriceps. Then more laterally we see biceps femoris. More caudally or caudolaterally we see the semitendinosus, and more medially we see the semimembranosus. What is very specific about 1, 2, and 3, which is very different from other animals, including the dog? What tuberosity, if I can palpate, what tuberosity I will palpate here? Ischiatic tuberosity, tuberosciaticum. And tuberosciaticum is usually the place of origin for all three of them. But in the horse, they extended further towards the sacrum and the caudal vertebrae, having vertebral heads. So what is the result of having the vertebral heads? We have the rounding of the crown, or rounding of the rump region of the horse. Okay, so that is because of the vertebral heads, and the other major reason is well-developed gluteal muscles. But even if the gluteal muscle was well-developed, this one may not really give that much of rounding, which is provided by these vertebral heads. Okay. Okay. Then as we go more distally, then we're going to see the muscles of the crus, or muscles in the leg. This region is also called gaskin. Okay, the caudal part, gaskin, leg, as well as crus, so the hind limb. Muscles which are located craniolaterally, muscles which are located caudomedially, same as other animals. Okay, two major groups: extensors of the digit, which are going to flex the hop, and flexors of the digit, which are going to extend the hop. Why is opposite than forelimb? Because of the flexor angle of the hock is opposite to that of the digital joints. How many joints are there in the digit? The fetlock, pastern, coffin. But all three of them, they are on the same side, they either flex on the same side and they extend on the same side. So we simply say extension of the digit, but it actually means that extends joints of the digit. Okay, so we never extend the forelimb. We extend the joints of the forelimb or specific joints of the forelimb. Okay, so extensor muscles of the digit and flexors of the hop. Flexor muscles of the digit, which are extensors of the hop. Now let's look at the extensors first. Okay, we get the flies there. Yeah, I think they look for us all the time. I don't know. We have some specimen back in the lab there. They are almost rotting, but the incinerator which actually we use for burning them is not working. So yeah, they're so bad, like they probably got some flies from there as well. So we have to be careful. They're trying to work on that one to get it going. So okay guys, so what so we know what's going on, why we have those many flies in the lab, which is unusual. Okay, so what muscle is this? The one which originates from the extensor fossa of the femur and then goes all the way down to the extensor process of the distal phalanx. That is your long digital extensor. Okay? As I lift up the long digital extensor and I free it up from its passages or from the grooves where it is fixed. Okay? What structure you cut in order to free up this muscle here? You cut 3 extensor retinaculum, not only one. As in the forelimb, you cut the proximal extensor retinaculum, you cut the middle extensor retinaculum, and you also cut the distal extensor retinaculum. So we had 3 of them which you need to cut in order to free up this muscle from its grooves or from its passages. Okay? Then what muscle is that? The one which is going further down, then again it becomes visible and then joins the long digital extensor. That is your lateral digital extensor. Now look at the importance or look at the necessity of the lateral digital extensor. Is it much necessary? Is this muscle much important in the horse? How many digits are there? Only one digit, so no lateral digit. There is no need of any movement of the lateral digit. So this becomes almost non-significant and then it joins the long digital extensor. Same thing is going to happen in the forelimb as well. But diffusion between common digital extensor and lateral digital extensor is not as obvious as it is in the hind limb. But you can say in both forelimb as well as hind limb, they usually fuse each other because there is no lateral digit to extend for lateral digital extensor. And so what we can do now, because this muscle is not so functional, not so significant, we can cut the tendon of the lateral digital extensor in order to relieve one of the clinical conditions or string heart. In the condition, what we get, like unusual, we can say spastic contraction of the lateral digital extensor, which causes what do you call that, like jerky flexions of the hop joint. Animal would lift up the hind limb and just keep something like this, and it happens once in a while. The condition is attributed to the toxicity of the grass or something, as well as like feeding, but there are some unknown causes as well. So what we simply do, we transit the tendon of the lateral digital extensor. You're going to palpate that as it runs along the lateral malleolus bone, and you find it out in that groove, and you simply cut the tendon.
It was already a little bit.
Quality made.
The retinaculum is really strong. Okay guys, so you're going to transit that one, and probably you're going to ask Rudy to replace one for you, okay? Okay, so the tendon can be cut here, and simply it relieves the condition. So that is the place where you're going to cut the tendon. Not below, not higher. This is the place where you can usually do that, okay? Okay, some other things here as we lift up the long digital extensor. Now, usually we can translate that one here, but we're not going to do that now because we already have freed up that muscle there. You can see the muscle located below that. Can you see the tendon, that ligament there? Okay, and that is your peroneus tertius. So what we see here, the peroneus tertius is no more a muscle. It has become a tendon, which runs between the extensor fossa of the femur to the proximal end of the metatarsal bone as well as some tarsal bones. The peroneus tertius is going to insert more on the lateral side, while your cranial tibial, which is located even below that. The cranial tibial is located right on the cranial surface of the tibia, same as ruminants. Okay, but unlike dog, where the cranial tibial is the superficial most one, and your peroneus longus and others are there, but in the dog we don't have peroneus tertius. Okay? In the ruminants we have both of them, peroneus tertius as well as peroneus longus. In the horse there is no peroneus longus, but their peroneus tertius is completely modified as a tendon or as a ligament. Okay? Again, when you say tendon, tendon is more associated with the muscle, but really that has now become a ligament, right from the extensor fossa to the proximal end of the metatarsal bones and tarsal bones. Okay, now what is the result of that tendinous nature of the peroneus tertius? What happens when the stifle is flexed? The extensor fossa is going to be pulled upward. The way the femur moves when the stifle is flexed, the extensor fossa or that part or the condyle of the femur is going to be like pulled a little bit upward, which is going to pull the tendon and pull the metatarsal bone upward, which will cause flexion of the hock. So what is going to happen? Every time animal flexes the stifle joint, the hock is going to be flexed because of the tendinous nature or ligamentous nature of the peroneus tertius. Now the same thing is present on the caudal surface or on the caudal aspect. I think that just keeps us from sleeping. Okay, then we have the superficial digital flexor, which comes from the. I just hope it doesn't go in the ear.
Did you
Okay.
shower today?
Pardon me?
Did you shower today?
What do you mean by today? It's months now. Okay, guys, so that is the supracondylar fossa, and the first insertion of the superficial digital flexor is the calcaneum tuberosity. So what if the stifle joint is extended? Again, the superficial digital flexor is almost as tendinous as the peroneus tertius, but slightly less than that. So what is going to happen to the hock? Extension of the stifle, the femur would become more vertical in nature, which would pull the ligament upward, and so it will pull the calcaneum tuberosity upward as well. What's going to happen? Extension of the hock. And so now what has happened to the hock? It is completely dependent on the movement of the stifle. The hock can only be extended when the stifle is extended, and it can only be flexed when the stifle is flexed. So the movements of the hock, they have become more passive, which depends on active extension and flexion of the stifle joint. Which muscle would extend the stifle joint? Quadriceps femoris. And so, because of hock's dependence on the stifle, they will also extend the hock, but indirectly or passively. So what do you call that mechanism? That is called reciprocal apparatus, in which the stifle and hock are coordinated and they move in unison. Okay? They cannot move independently in the horse. Okay, the muscle cranial tibial also has an ability to flex the hock joint. But as long as the stifle is not extended, the hock can stifle is not flexed, the hock cannot be flexed. So the cranial tibial almost becomes unnecessary or insignificant in the horse. And so again, as the lateral digital extensor is not significant, not much functional, we can cut the tendon, or we can afford to cut the tendon of the lateral digital extensor. Same thing we can do with the cranial tibial. The tendon of the cranial tibial, which runs on the medial aspect of the hock to get attached to the first and second fused tarsal bones, can be cut to relieve the pressure on the bones, or to pressure on the bursa. Okay? What you have there, like this one, Where is that? That needs to be replaced, yeah. So
Leave
this
the
one,
trick on that.
see the bursa is located right here. And so what you can do, like if the bursa is damaged to a certain extent that it cannot be now reversed, we already have formed a lot of exostosis and a lot of formation of the bone there, which you cannot do anything with. So you're gonna cut the tendon and just leave it as it is.